to 60 minutes.
Okay.
All right. Let me.
I see the live button. I think we're on.
Yeah, I think that should be it.
So are we supposed to come up with our own experiment as a group or assignment exactly?
I thought it was just brainstorming ideas. Is that?
I think that's what it is too, but I'm also not fully sure.
All right, this is what it says. It says, for this week's group activity, come up with a series of experiments that you would like to conduct to test the theory of plate tectonics. We have all the money and time we want. So,
how come we do that?
well, one of the things that I learned about as I was working on my annotated bibliography for this week involved research that they had placed measuring devices out along the Juan de Fuca plate, and they were out in the ocean and also adjoining plates to them, and they were testing to see how much movement is happening over time, and they have so many out there that they can have a lot of detection, because what might be moving in one spot of the plate might not yet be in motion at the other end of the plate. So I was kind of intrigued by that, because I thought if we're able to do that on that smaller scale, you know, how do they do that like out in the center basin areas where there might be diverging plates happening, you know, spreading apart? Do they have, could we put stuff out there to see how fast those parts are diverging apart? So that would be fun to me. And then could you go down in those little submersible mini submarine things that they used to show in Jacques Cousteau for us old people? You probably don't even know about them, but you know, and go down and place these with these robotic arms down in all the different locations, and monitor the steam vents that are coming up through the ocean, and does the amount of steam and the makeup of the chemicals that are in the steam vent coming through, does that affect and change when there's motion on the plates? Those were the thoughts that I had so far.
Yeah. I think in my science foundations class last semester, it said that my teacher said they have GPS units on a lot of on most, if not all, of the plates, so you can sort of track the movement. I thought that's really cool. You just have there's a GPS on one part of the plate, and then you measure exactly how fast and which direction it's moving.
Mm-hmm.
So you've got at least some of that.
Mm-hmm. So our two ideas would help measure things that are happening now and in the future. So is there any way to figure out other testing to justify previous movement, like you know, there's the theories about Pangea and the motion that changed to create the globe the way that we know it now. And the reading had some examples of ways that they were able to find, what was it, some plant life and some worm stuff, and some other animals were together in certain continents that are no longer near each other at all, but because of how they were there, you know, now they're seeing them and they can date them and find out when those came there. That's how they're able to determine that certain continents might have been much closer together, or probably were much closer together than what they are now.
I remember that part in the lesson. Yeah.
So what else could we test about plate tectonics? We've got motion.
Um, try to test like how to know what's going to happen when they come together. Maybe.
So for converging plates, you're saying coming up with models for what the result of those converging plates would be?
Yeah. Yeah. Trying to open up the textbook and try to get some ideas from that.
Mm-hmm.
I read about a 5th grade experiment they did in my school, but it's just, I mean, it's just for 5th graders. I don't know if think about anything like that, but 2 pie plates and they fill them up with water. Styrofoam cups, 12 pieces, and those will be like the 12 plates. So they put them on top of the water, will represent the magma, right? And the styrofoam pieces will be the plates. So they did is they will move the pie plate into the water. The water starts spilling. So then they start, you start thinking about, so when the water, when the earth moves, or the movement underneath moves, what happens to the magma? Then it has to go up somehow. Then what they did also was moving the pieces of the styrofoam together and see what they do. So when they, they use fingers, so you just move them a little bit, and then they will touch each other and they will go up. Sometimes the magma will spill in between the pieces of styrofoam. So that will be what the magma will do. Happens here. Then you have volcano erupting. And also what they did was put in 1 pie plate, one on top. And then what happens? Then all the water spills out. Plate on the top was very heavy when parts of the plates are moving towards each other, right? Gets on top of the other. So that was very interesting. That will help with this activity, but.
Mm-hmm. So that would pose some interesting ideas, though, because that's just a general basic way of looking at it. But how could you expand that to be in a more of a real world situation? Are there aspects of that experiment that could be used in a real world setting?
I don't know. To go back and read about the report that they see how far they went with that.
So like I'm thinking in Hawaii, they have parts of the islands that are active volcanoes, and the magma is coming out from the earth in various places and hits the water. And the water then gets heated because of the hot magma, or lava actually, because it's coming out of the ground. So once it is above the ground level, it's called lava. So when the lava is out and then it reaches the water, changes the temperature of the water and increases the size of the land. But if that happened a whole bunch, like if there was suddenly a lot of lava coming out rather than just the slow amounts that happen now, I wonder if that could be measured and then determine if they were using the GPS system, what plates were moving around at the time that caused that increase in the lava flow. because there's a couple of things that could happen. If the plates are converging, so they're coming closer together on one section, does that mean they're moving further apart on the opposite side of the plate from the next plate that they're touching? Or are they coming closer together and converging because there is an area in the middle of the plate or a couple different areas within the plate that are diverging, and that's causing it to spread wider, which makes it bump into the adjacent plates as a converging state. So plates could be doing convergent and divergent motions all at the same time. And maybe that would be something that could be studied is, what is the relativity of the divergent motion, and compare that with the amount of convergent motion within the same plate.
Yeah, that sounds like if like one side of the plate grows, and like on the other side, like after all the other stuff happens, like it goes down to the next plate, and like with the other side of the plate, then like pushed under. Because so would have some other one get pushed over it if you move it to the other side, like the whole like a domino effect sort of thing.
Yeah, that's what I'm thinking. Because like in general physics, when something moves, it affects something else. If a ball bumps another ball, it's going to cause that ball to move, and the first ball leaves empty space where it used to be. So I'm thinking that same principle probably applies to some degree within the motion of the plates, because when something moves, something has to fill in that space that's caused. Like for the divergent, where they're coming up and they're splitting further apart, they showed how the magma is coming up through the area that has been created. The what do they call those? It's not a canyon. It's a what? It fell out of my head.
Where the plates pull apart.
Yeah, where they're pulling. What's
The ridges, like
the chasm?
Oh.
There was a word, I can't find it in my head. Anyway, as those are created, the magma from underneath the mantle starts to move upwards and fills in that space that's being created as they're separating further apart. So I'm just imagining as it's coming up and it's separating further apart, that and going like this, then over here where my thumbs are, my hand is a whole unit. So if I'm coming like this and this is moving apart here, then it's moving my thumbs further apart, and they're going to bump into something else over on this side as well, even though things are getting filled up within this space.
Yeah.
Kind of confusing, but
Yeah. I wonder how like that applies to, like, because if it pushes out this way, like how come all the plates are moving in different directions? Like, if this goes out this way, and then it hits some other plate, how come like some plates are going this way over a plate that's going like this way, sort of thing?
yeah.
How does that happen? Like, how does that?
I was gonna say we have to think that it doesn't happen very fast.
Yeah.
Are slow.
I think my teacher said that like some of the faster plates grow as fast as your fingernails grow. That's how fast.
Yeah. That was in the reading material too. It was
Yeah,
like 2 to 5 centimeters a year, depending on the type of plate motion, which isn't very much, but if you added it all up over a long period of time, it would be.
Yeah. And so you have like Pangea and all the other.
Right.
So when you think about when they are moving so slowly, like 5 centimeters a year, then whatever they are moving next to it, right? So everything, it has time to build. Explain myself better. But if the plates are moving 5 centimeters a year, if they're diverging or in any other movement, it goes slow. So whatever they move at the same time, because they're pushing something, right? it happens slow too. We're talking about 100, million years from now, we will see how far they have moved, right? And then we see what they have pushed in 100 years from now, what they have pushed to the side or in front of them, or these changes fast. It happens very, very slowly. So if it will happen fast, it will be like a domino effect, and then we'll see, ooh, something fell, and then it pushes. It happens so slowly. The result or whatever it looks later is very different than if it would be a movement fast, like when a volcano erupts, right? It explodes, then it solidifies, then it builds more rocks or a mountain or whatever, and then that happens really fast instead of the plates movements that are so slow. I don't know if I'm explaining myself.
You are, and you talked about having, if you could wait for 100 years, and part of this question is if money and time don't matter, then you could do an experiment like that where you have something that stays, and maybe you're the scientist that sets up the program for testing, but it's, I don't know, a century, maybe it's 1,000 years before the results of what you have set up are measured. But as you said, you could see where it is now, and in 100 years, see where those different measuring devices are located. And then you would see the directions. Are they just strictly east-west? Are they shifting? They started east-west, but then they rotated and started heading northwest or whatever. And then once you have data from 1,000 years time, or even several hundred years time, then you could use the technology of time-lapse photography to to smoosh it all together and see, well, this is what really did move. And we can watch it in an hour to see how far it's traveled in 1,000 years, so to speak.
Yeah. It's like when we have these construction companies building something really big, and they are using cameras to record the building of something.
Yeah.
Well, it takes years, right? But then you fast forward, and then you can see it really fast. How,
Mm-hmm.
the same thing we could do with measuring, the movement of the plates. Then we put it all together and we see how fast and which direction did they go. And
yeah, so I'd be curious to set that up on not just on one side of the set of plates, but so that you could hit like all the edges of several plates that are touching each other to see, do they shift this way as they're moving, or does it this way, or is it all this way? Because are some plates getting bigger because they are, what was it, the more dense plates are the ones that would go underneath, and so so those plates would technically be getting smaller in size, but the lighter plates would be getting larger in an overall area because they're staying up above what is happening.
Yeah. I guess you're talking about the time lapse sort of thing. That's you sort of like look at something you can kind of see now is like something like the island chain, like the Hawaiian Islands. How they it's like because that's over one hot spot. So then I guess you see like the distance between each island. You can sort of see like that can sort of be like your time lapse now.
Yeah, because those are physical structures. You could set up monitoring on different locations on each of the islands and see how their rotations or movements in relation to each other. Is that changing? Are they moving further apart? Are they being pushed closer together?
Yeah.
And see, does that affect the volcanic activity on the islands based on whether they're being pulled apart or pushed together?
Yeah.
We haven't really talked about volcanoes at this point in time, but in my area, there's we have Mount St. Helens, we have Mount Hood, we have lots of mountain ranges, and so volcanic activity around here has just always discussed with plate movement. It's just like they go hand in hand because that's something that we live with here.
That's the sort of, I have that same thing with, Southern California. There's California sort of thought of like always like the big ones, man. With various spots, same sort of thing. I guess we got like I was talking about earthquakes and how that's with the plates moving back and forth or moving together.
So I was intrigued by one of the things that I read in this week's assignment about Southern California. What's the name of that? Baja California? Is that peninsula this time? Yeah. That eventually, if the plates continue moving as they're doing right now, that eventually that will be clear up north of Washington at some point in time. And I thought that would be a lot of movement. So I was wondering how many thousands of years would it take if that really breaks off and shifts upward? How many thousands of years would that take to get from where it is now up north, heading towards Canada and Alaska?
Yeah, I think that'd have to be like millions of years. That'd be so long. I think just out of that's so far. I guess just what I'd say. Mm-hmm. Travel all the way up there.
And I wonder if there's certain times when it's possible that the plates pick up their speed of motion. Is there something that happens that maybe makes a plate move faster than just its 2 to 5 centimeters a year? Certain kind of either activity with the mantle or an adjacent plate or whatever that might increase the movement of another plate.
It probably is something like that.
So how would we measure that, I wonder?
I guess if you've got like the GPS thing and you're tracking how far the plate's moving, some of the previous times you would look and it'd be like, well, this one was moving 2 centimeters, and like the next year moving 5, and we're back down to 2, and try to see that. But then how would you know what caused it?
I suppose because the Earth is so interconnected with everything that you would also have to track what might be happening on the opposite end of a continent to see if that is affecting what you're seeing happening.
I was picturing plates. Like the African plate was moving at like 2, and then suddenly it was moving at like 5. Then you see that that's because the South American is moving at the South American dropped from like 5 to 3. So one plate started moving faster, and the other plate slower.
Mm. Yeah, and I wonder if if the size of the overall plate, like would a smaller plate, like the one a Fuca plate, does that move at a different speed than, say, the Pacific plate or one of the other larger plates? And again, that GPS or those underwater monitors would be able to quantify that information.
I just got a text from Jeremy, the other guy in the group, who just said he's gonna be there. He'll be on in a few minutes.
Okay, great. He might have some other ideas for us.
Yeah. I'm gonna look up like the directions that all the plates are moving.
I mostly had just focused on the ones off of Oregon area because my topic for my annotated bibliography is coastal processes. And since our GeoJournal is also about our area, that's where I've been doing most of my focus, is how that works here. And it is interesting to see how there are some places where you have plates that are moving this way, and then there's another one on the other side that's moving this way at the same time, and how everything is in that slow motion-y kind of way. And I don't know, I was thinking, if you, like, we know that God's time is different than our time, so I'm thinking to him it's probably happens a lot faster when he's watching all of this transpire, and he can see how all those different things move. So
Yeah. Were you the one that said like something like that you were in the annotated bibliography or something like that you like off of like the 5 freeway, the interstate, something like that?
they're off of I-5, you've got you cross over the Columbia River, which separates Oregon and Washington. Is that what you were talking about?
Yeah.
Yeah. Oh, yeah. And so that's one area where you cross that space. But in that area, it's all city on both sides of the river, or piers for shipping lanes to come and go. But if you head further east, that's when you're in the more natural areas. And that's where you have the big gorge area there, is further east down I-84. And that's where you can see the different layerings of the rocks, and you can see the lines of the sedimentary rocks that have been pushed up at various angles. And it's so interesting to drive through and see it's going along like this, and then all of a sudden you hit a spot and you can see across the gorge, and the rocks lines for the sedimentary rocks are doing this.
Yeah.
And sometimes they're straight up and down, and sometimes they're just kind of like little wavy things. And it is very interesting to notice the different types of rock formation all through that area, and try and figure out, well, does that mean this section dropped? And when it dropped, that pushed the neighboring section up higher? Or was there something underneath that higher section that just pushed that one section up high and left everything else the way that it was originally? So it's pretty interesting for me to try and guess that. That's one of the ways I kind of stay awake as I'm driving through that like 4 or 5 hour section of roadway. I'm like, okay, see that rock? What's caused that formation to happen? And then you can see different colors of rocks as well. And then when you're heading down into Utah, and you get down, between Logan and all that area, and then you start hitting places where there's pockets of red and orange soil in the middle of the rock, and you can see where they're mining the different colors of rock and other minerals or whatever that are there. And you think, well, why is this here, but it's not over where I was 8 hours ago driving by? They just have brown dirt over there.
Yeah. That's weird. Like, that's got to be something with the plate tectonics. Who knows?
Yeah, or the different makeup of all the rocks, and we talked about all the different rock processes, about igneous and metamorphic and sedimentary, and how they're formed and different things. And it makes sense that they would be different and have other characteristics that separate them from the other rocks.
Yeah.
I wonder if any of the huge mining operations that we have going on, like I know there's huge mining places all through several areas in Utah. I wonder if any of the disruption that they do of the mountain structure as they're pulling out the different ores and different things from that, or with the oil fracking that they're doing in, is it North Dakota or South Dakota? North Dakota? I can't remember. Does any of that affect the motion of the plates because of the stress we're causing so deep down on the earth? Because, like I said, everything we do causes a reaction somewhere else, and a lot of times I don't think we realize what we're doing now is affecting something else later.
Yeah, actually, I think my brother is serving his mission in Oklahoma, and I think he said that there's been a bunch of earthquakes, and that they're saying that it's from all the fracking that's been going on.
So look at my blog, because there is a link there that I found to a website that the National Geology or Geography Institute, somebody does, that tracks earthquake activity around the globe, and you can zero in on anywhere on the earth, and you can see in the last 30 days, it has all little dots where activity was detected, and then it updates every 15 minutes, which I guess would be kind of like watching the baby giraffe get born, but you can, sit there forever and watch it. But it was interesting because you could spread out, you could see the whole earth and what's happening all over the whole earth, or you could narrow in on a specific area. And I was surprised how many earthquakes had been recorded in the last 30 days just in my area. And we were in Utah a lot in the month of March, and there were a lot of earthquakes down in the Salt Lake, Utah Valley, Wasatch Front area. Not that I felt any, but
Yeah.
And Oklahoma does have a lot more. Yeah, I had some in-laws that had been down there, and that was their thing. When they first moved there were hardly any earthquakes. In the last 3 years they lived there, all the time. They were happening all the time. So
I think it has a lot to do with what we're doing to the earth, how down we're drilling to affect, all the ocean, layers and the crust and everything. I mean, we're not supposed to do this to the earth. It's like drilling holes to our brain or something. It has to affect the earth. It has to.
So speaking of drilling, I wonder whether there are areas on the West Coast where they have ocean oil rigs and down, actually a lot more down in the Gulf of Mexico, where they're drilling for oil down in that area. I wonder if any of that affects the motion of the plates that are in those general areas. If that would be something interesting to research as well, to see what the if that affects the motion of the existing plate or adjacent plates, because you're displacing stuff. Whatever you if you have a bowl of water and you put another bowl on top, just like your pie experiment, the water has to go somewhere. If you're drilling down in, the stuff you're displacing has to go somewhere also. So, sorry, I realize it's getting dark where I am, so.
Yeah.
Well, I have to go. I have to help my daughter, my oldest daughter. How many more minutes are you guys gonna be on?
Well, we started, I think, was it a quarter after?
Yeah.
I think something like that.
So we still have to discuss for at least another minimum of 10 minutes, probably 15 to 20 would be better, but you need to go? Yeah. Well, maybe Jeremy will get on soon and we can pull him into the discussion.
Yeah.
Definitely the last little bit.
So we'll submit this recording.
I don't know how to do that.
Yeah.
How do we?
I think when I press the stop broadcast, there'll be a link to it on my YouTube channel that I had to make for this.
Yes.
Oh, so you're the hero. Hooray for Darren.
Once this is over, I'll try to figure out where all the links is.
So do I have to do anything individually or not?
I think it was just a group discussion, bouncing ideas off and kind of learning from each other.
And then there's a quiz that we have to do, and where is it? The quiz is basically like if you click on the group activity, it's just a quiz. Is what it ends up being, and you answer. You paste the link to the video, and then let me see. I'm pulling it up right now.
Okay.
I think then you rate how well each person did and how well you thought you did.
Mm.
And then you submit that for him to see.
Nice.
Okay. So how can I be fair with the other person that is coming in and I will not even know what he's saying? So I just don't. Who's in this bathroom?
Yeah, you just have to say that that you had to leave before he was part of the groups here and able to rate his participation
Yeah.
or something.
All right. Are we meeting every week at the same time and the same day, or what?
I don't know. That works for me. What do you guys want to do?
I can meet the same time. That'd be fine with me.
I know I do have a stake meeting next Thursday, but I'm going to end up missing this and my other course meeting. If we could move this one to a different day next week, that would be helpful to me. But we could talk about that via email. Does that work?
Sure. Yes.
Because we need to get Jeremy, and I think there's one other person too. Aren't there 5? I thought there were 5 people.
There, I'll go check.
I'll check the email and then you let me know what we're doing for next week then.
That sounds great.
Thank you. It was nice meeting you.
Nice meeting you. See you next week.
Yeah. Yeah.
Bye. So Darren, what other kinds of things can we talk about with relating to plate tectonics? So we've talked about those physical changes to the earth.
Other things, but I guess what I know plate tectonics does is it makes the mountains and volcanoes and how the plates move and earthquakes.
So since the plate motions make the mountains, we could also measure how much taller they're growing over time.
Yeah.
Right? Because it would seem to me like that if the plate motions are increasing that are causing the mountains to be built, that the mountains would be growing taller.
Yeah. I think what I heard was that when an earthquake happens, Mount Everest can if it's like a big enough earthquake, and depending on when the last earthquake was at Mount Everest, it can grow it can shoot up 8 feet at once.
Wow.
So,
But that's a lot bigger than 2 to 5 centimeters of change.
Yeah, but I think that's because the plates are stuck together.
Uh-huh.
And they finally I don't think the plates actually move 2 to 5 centimeters each year. I think they sort of stay together. I think the San Andreas Fault. They always talk about that. That's why.
That's fine.
The strike slip, and I think it's what they say is it moves 3 centimeters a year, but it gets stuck and doesn't move until the pressure builds up enough, and then it shoots.
Oh, to make up for the fact that it couldn't go before, then it's okay, then I'm really mad now, and I'm really going to move now.
Yeah, it's that sort of thing. So you don't see all that's constant movement. I don't think. I think it's every couple million years or whatever. Every maybe not that much. Every 100 or so years, 1,000 years, something shoots a huge distance.
Oh, there's Jeremy. Hi, Jeremy.
How are you guys?
We're good.
Yeah.
Sorry about that.
So we've been talking about several different ideas. Things that we could measure for plate tectonics.
Yeah.
We've talked about putting things out on the ocean to measure motion of the different plates that are next to each other. Potential for seeing as they are coming up and doing divergent motion, is that causing convergent motion on the opposite sides of the divergent motion for those same plates, or seeing if the plates that are what's it called when they're going underneath?
That's subduction.
Subduction, yes, thank you. When they're subducting.
Oh, subduction, yeah.
Yeah, is that motion faster or slower than converging or diverging? We talked about measuring the mountains that are being brought up or the volcanoes that are coming up from the plate motions, and seeing how the rate of growth is for those compared to the amount of motion that the plates are experiencing that are associated with those particular mountains or volcanic regions. What else did we talk about, Darren?
we talked about like earthquakes and how, or what was it? More better. The plates move this way. If the plates are moving apart, how do they affect somewhere else? Yeah.
That's right, because we brought up like in physics where when something moves, it causes something else to respond to it. And so what's happening on the backside when the plate is shifting this way? What's happening on the backside way over here? Is it shifting everything this way, or is it really shifting this way and this way? And what's happening on both sides? So plates could be doing convergent and divergent motions within the same time frame. So mostly it was a lot about posting
Never
monitors.
thought of that.
So those were ideas. We're posting monitors in the ocean and on mountaintops and judging motion. And oh, Darren had a really good idea too about putting monitors like in the Hawaiian Islands that already have volcanoes or mountain structures, islands that are close enough together that you could actually measure how are they moving as a unit this way, or are they moving this way or this way? And they probably have those things set up all over the islands already.
Yeah.
I wonder if you could see anything from outer space about the motion of the plates, or if it's just more local that you could measure things.
That's kind of what I was thinking about. I wonder if they could use the satellites or something. You know, and have some kind of, well, maybe you guys mentioned it, like sensors or something like that. On like that, or on the ground and type of deal.
I suppose if they had up on the mountains something that could relay data up to the satellites, and maybe that's how that technology works right now, is that they send data up to a satellite and it's sent back down to a receiver somewhere else, and they're judging the motion distances.
I think it'd be really cool, like having a time lapse from space, seeing how it all moves. Like there's always these videos, like the animated videos. That'd be really cool, like see in real life. See all the plates move there. See like Pangea form. I guess what it says time and money isn't a problem. One thing I'd like to see would be setting up a satellite or like a camera in space looking down on the Earth over like millions of years to watch like a new supercontinent Pangea type thing to form.
Mm-hmm. Well, I wonder if we get a little taste of that just with the volcanic activity that happens in the islands of Hawaii, because you can see the lava coming out and forming new land over time and building it up. I know that when I was in high school in Mount St. Helens, before Mount St. Helens erupted, they had monitors up there that were monitoring the dome activity, because they could see a growth happening in an area that was carved out of the mountain. And so as they watched this dome building, it would just keep building up, and they would watch to see, well, how much is it changing? Is there increase in plume activity and all these different things? And then it was kind of like your description of the San Andreas Fault. It just does little bits of motion and then just kind of gets stuck, and then one day it just gets really angry and it just goes and has a big jump. And that's the same thing that experienced with Mount St. Helens. It was just lots of little motions, and then to reach the point where they couldn't even do the little motions, and it had to just do a big jump to ease the pressure that was building up from it. And yeah, so like I'd be curious, just because I've seen that visual of the outer structure resulting from motion happening down deep under the ground and in the earth, I'd be curious what motions the plates were doing in these areas that contributed to that. Because we know all of that's connected to the same system. They talked about that in the video, that the areas around the North Coast, the northwestern coast and down, and North America and South America, down along Peru, those mountain ranges were caused by the plates crashing together in those areas. So, is there an area as deep as Mount St. Helens somewhere off the coast, kind of balancing out the growth of that mountain and the other mountains? Like, because they talked about one of the pictures that it had of the Earth showed the mountain ranges, and then it had on the coastline, I don't know how many miles out to sea it is, but there are areas where it showed that there was those big chasms down in the ocean floor, where the plates had diverged apart as it was coming closer to join the other plates. I wonder what the temperatures are like in some of those super deep caverns, because the ocean is very cold in many places. So in the deepest part of those, where it's like really black and they don't have much life down there, animal life and the ocean life, is it much colder down there, or does it get hotter the closer it gets towards the mantle area, because it's near the mantle?
Yeah, you think that it should be probably really cold from the water and the light down there. But I guess there's the heat from underneath the crust that should probably is creating a lot of heat.
Yeah.
Heating the water a lot.
Maybe that could be a
near those lines, those fault lines, it would be warmer.
yeah. So that would be something interesting to measure as well, is a part of the plate tectonic thing. Motion is when more motion is going to be starting to happen, do the temperatures increase in those areas from what they were, 20 years ago or 10 years ago? Is it warmer now because the plates are receiving more pressure and are going to be moving more? Does that pressure translate into heat?
That'd be cool to see. Like, yeah, if it's getting a lot warmer, does that mean it's about to move? It's about to the plate's about to move a bunch, or does that mean it's moving faster if it's warmer?
Yeah. That could be a good predictor of earthquake activity if temperature was one of the things that was an indicator of motion.
Yeah.
So Jeremy, do you have any other thoughts about ways that we could do experiments to test the theory of plate tectonics?
One thing I was thinking of was like trying to figure a way to move, like whether you have like a detonator or something, to cause some of the motion and that sort of thing, that you can test them. But
To get them to move on purpose, you mean?
yes,
Mm.
that you could study them that way. The only thing with that is probably each one would be, you'd have a different amount, I guess, that would cause it, each one, because each one or every plate line is going to be different, structure wise, and to get it to move probably take more or less type of a thing. So I don't know, that's one thing I was thinking of. But
So if
you guys got it mostly covered.
I don't know. So that it brings another thought to me. If one is trying to manipulate the plates, what would the purpose be of purposely manipulating a plate? I mean, technically, if you're manipulating a plate and it's causing earthquake activity in the ocean, this could result in a tsunami. So if, say, we happen to be at war with Japan and we're able to set something off in just the right location that would create a tsunami that would cause destruction, that could be
Yeah, very true.
interesting, but not in a happy way.
Yeah. That'd be really cool. There's the same amount of energy that it takes to make the plates move.
Yeah, on that side of it, it would be, but
yeah, it would be nice to be the receiving end.
No.
I don't know. It'd just be hard I guess my thought process behind that was try to manipulate like the forces coming up to get them to move, but that would be on, you know, the top side of it. You know, from our end of it, trying to go down, it would definitely be different. So I guess you'd have a different effect than, you know, what would be natural.
Well, if you were able to do that so that you could, say, get a volcano to release its energy and be done with what destruction it was going to do, so that then life could then continue on in that area, you know, that would be a beneficial thing, because there are so many areas where it's just the slow, constant threat, and some days are worse than others, but you're just always living under that that stress or worry about, well, is today the day that the lava is going to move quickly and take out my house, you know, or my town or whatever, versus let's just do it and get it done. Because that's what happened with Mount St. Helens. Finally, it just did it and it was done. And, you know, some little stuff since then, but it wasn't a pleasant thing when it happened. But once it was done, then it allowed things to be able to get back to normal again.
Right.
So it could be a positive effect on humans if you can do that.
Yeah, it could. Yeah. They say get it done and over with.
Mm-hmm. But
What really lies underneath, you don't know what's lurching and what's gonna happen, I guess, too.
Yeah, because that's one of the things that we've talked about quite a bit, is that when you do something, it always affects something else, and you don't always know what that other thing's going to be.
The ripple effect.
Mm-hmm.
Yeah, other than that, I can't really think of anything else other than what you guys talked about already.
We also talked about if you had those monitors set up, that you would watch, and you watched it over thousands of years, then you could use, you know, fast motion photography to see how the whole thing progressed over that period of time, and see the changes that would happen. So the work that you would do now for setting up experiments, probably the results that you would see wouldn't be available for hundreds or thousands of years down the road, but then they would have greater understanding of how the Earth's plates are moving.
Right. Yeah, because you could also, along with that, you could have the sensors where they have alignment, you know, so like you can actually see, you know, they can adjust for the distance that they move apart from each other, or if they shift opposite directions too.
Mm-hmm. Yeah.
So.
Sounds good. And something that I read a little bit about was dealing with the polarity of the plates, and I didn't really understand that, and maybe that's something that comes. I still have a little bit left to read in the chapter, but maybe that's something that comes there or later on when we're talking about other geology activities. They were talking about the polarity of the plates in relation to each other, that some had polarity that was going this direction and others had polarity that was going this direction. And I couldn't tell if they were referring to the actual motion of the plate, or if there was actual like magnetic activity that was changing within the plate structure based on the motion of the plate, and how thick or how thin the mantle was in those areas.
What was that
Interesting.
polarity? Does that mean like the magnet and how like?
That's what I was thinking, but the part that I read about when I was doing some of my research, it was a bit over my head. And so I was trying to understand, you know, we're reading these documents for our annotated bibliography, and I'm trying to grasp things, and it's talking about the polarity, and I think it had to do with the thickness of the mantle affected the polarity, but I couldn't tell if the polarity meant the magnetic polarity, and if the magnetic polarity was increasing the motion of the plates in one way or another. And that's another thing that a person, I suppose, could experiment with is the polarity of plates.
Yeah.
You know, in relation to magnetic north, are the plates rotating? Are they staying the same? And do magnetic fields change the motion of the plant plates or not? So many questions.
Yeah.
You mentioned that because polarity system, and so there are poles, and I think that within each boundary line you would have, opposite poles or polarity in each,
On each
crevice
plate.
of that. Yeah, of each plate. So, yeah, I would imagine. Yeah, that would be something to. If that's actually true, then you could do something with that magnetism and off of those boundary lines.
Yeah.
Okay, Darren, sum up what we talked about.
So we discussed finding like tracking like the movement with like GPSs on the continents, and like, that was a lot of the concept. Like with that, on like all the plates, and like, specifically where the plates are and where like farther away to see like if like if the inside, if the middle and the out edges are like moving the same speed, then trying to find the magnet, the polarity, or seeing how that affects the motion of the plates.
So a lot of our measurement might have to be out in the ocean because that's where a lot of the plate edges are. That's where they happen, right?
Yeah. A lot of I have a picture somewhere.
Because the plate edges kind of follow the structures of the exposed land.
Yeah.
Yeah. So you'd have to do a lot of the work would be out in the ocean.
Yeah.
And one of the things we talked about was seeing if heat affected the motion of the plates, sped up or slowed down, or was an indicator that motion would be happening.
Yeah.
Just like, when you rub your hands together, that friction makes them warmer, right?
Yeah.
So if the plates, but does it have to, and maybe it has to be fast motion, but if it's pushing really hard, like the plates would be pushing really hard, maybe that creates enough friction that there would be heat even though they move slowly.
Yeah. With that much mass, you have to still treat a bunch of heat.
I wonder if transverse motion produces more heat than like convergent motion. Divergent seems more peaceful to me because it's coming apart, but when they're coming together, I think that would be a lot more destructive.
Probably a lot more friction with that.
Yeah.
That's how it turns the crust back into magma.
Yeah.
Friction.
Yep. Okay. All right. That's the beauty of it being an experiment. It doesn't have to be a real answer. It's just, what are the possibilities? What are the possibilities? Okay. So are we at the point where we are done recording our session? Do we want to end our recording and plan for next week?
Yeah, sure. I think I just looked it up. I think it says we've been streaming for almost exactly 60 minutes now. I think it says 59.
Okay.
I'll stop it and we'll